Alright, so I do apologize sincerely if my fan is being loud in the background, but it's quite warm right now where I live, so that's on. Hopefully it's not too loud. Um, so what do I have for you guys today? So first things first, just some things I'd like to show you. Interesting stuff. What first? Um, Alrighty, so as far as I remember, let's ignore these two because I'm not on this BIOS anymore. This is meant for more like comparative purposes on OCN. But this profile, uh, as well as this profile, this one, and this one, all destabilized after a few days. And this was like shortly after I did some benchmarking on 3DMark. Funny enough, let me just gloat a bit real quick. Now it's not anything insane, but I finally did crack it. So I managed. Please tell me I'm still. There we go. No, I'm still there. Okay, cool. So I'm still 38th. I think it was 37th that night, but I dropped to 38th because someone else posted a score. But yeah, I'm top 40 in the World Fire Strike right now. And if we go to Africa, single GPU obviously because I'm a peasant. I can't afford more than one 69 XT with my crappy side job that I do, that I pour all my cash into, or cash from, to buy this crap. GPU count 1. Okay, so let's stop time spy because it's at the top. So I'm number 1. I don't know how, because as you can see, this is pretty weird. By the way, not trying to bash this guy on second or anything like that, but look at my CPU score, look at his CPU score, look at the clock speeds. what the hell? That makes absolutely no sense. And by the way, to achieve this clock speed, can I even say it? I'm gonna say it because I'm selling this chip in like 3-4 years. I don't even care. Yeah, so I don't think this kind of thing will cause degradation, but to run this benchmark, I had to use like 1.47 volts with like LLC number 3, and that yielded like 1.35 load voltage because of the VDROOP, because it's quite high on this board. LLC3, the VDROOP is like over 100 millivolts, so it runs this benchmark at like 1.35, 36, maybe 37 volts. Times by his physics test, it's pretty heavy. Well, heavy-ish, and at the temperature it was running at, because of the current draw, it was fine. Like, it wasn't crashing, it wasn't heat crashing. If I run anything over 1.3 volts, like well over 1.3 volts at load, I almost like immediately heat crash. So anything that can degrade me, basically immune from, because if I get to the territory of degradation where it's like the chip is running really warm with really high load voltage, I just fucking crash like immediately. Like it just crashes me like almost within like seconds, like tenths of a second. No, not tenths, like a second, literally. Like start test crash like immediately. Like there's no way. Like anything over 1.3 load volts that hits like 100C or 105C and immediately, that's crash immediately, like done. So I'd like to think I'm immune from degradation, but I mean, I saw some mad shit yesterday at my friend's house, or like a few days at my friend's house. I overclocked, so if I go to, do I want to go to IG on my? I'll go to Facebook. Screw it. Alright, so if I go to Dane, so yeah, I sold my friend this board that I bought from another person on Carbonite. Because he needed. So my friend hates spending money, right? He's a really good guy. My friend Jason. He hates spending money because he loves investing and he loves like looking towards the future. But I was like, dude, you've been using a 9900K with crappy RAM for like the last 3 fucking years. Like, dude, please upgrade. And he's like, no, it's too expensive. I'm like, okay, I'll find a way for you to upgrade that'll cost you nothing, and you just have to buy the parts. I'll link everything. Buy them when I tell you it's a good deal, and that's it. So he bought 2x16 4400 C19 Micron Rev B. This kit was like 8 grand here in South Africa. This kit was sold for like less than half price. He got it like for 3,800. That's incredibly cheap. That's like $200, something like that. And then I sold him the board for like let's not even talk about it. It's like this board is worth like almost like triple what I sold it to him for. because I bought it for that price, so I didn't want to flip it on him. But this board is like, yeah, like whatever. I was never gonna use it, so I figured fuck it, like I'll give it to him because at least it needs to upgrade. The chip we found him was a sealed 11900K for 6.5 grand, which would seem pretty expensive, but the thing is, it's more than a 12600K cost here, but this board makes up for it. And yeah, so his platform upgrade cost him like $100. So he went from a Z390 Ultra 9900K to a 11900K Tachyon build for $100 more. It's like, it's fucking brilliant, isn't it? Like, that's just brilliant. Like, can't make this shit up. Anyway, so I noticed that what is that about to say? Oh yeah, his chip was trying to boost to 1.52 volts at stock, right? At stock, and with Intel adaptive boost on, this chip was trying to boost to 1.65 volts at load. Bro, I shut that shit off in like 30 seconds. Not even, no. When I saw it, it took me like 10 seconds to like determine, no, this is not coming down. Like, that's just, it's trying to complete the workload at 240 watts because it thinks it has headroom. And I'm like, CPU, you have no headroom. Please come back down to reality. Like, so I basically just dropped his voltage down at like a fixed voltage because I was gonna OC it for him regardless. But yeah, Intel adaptive boost, weird. Weird. Like, I literally changed nothing and just adaptive boost, tried it balanced, and just fucking forget about it. Like, forget about it. Anyway, so these Intel chips are quite resilient. Now, when I say that, don't fucking go try and put 1.6 volts through your chip. Like, if you really want to benchmark, you can stop at 1.5 with a conservative LLC with some reasonable cooling, and it should V-droop down to like 1.35 to 1.37 at load, and that should still be perfectly fine for short intervals of testing. That might degrade your chip by like a millivolt after being done, like if you do it properly, right? And you might see the degradation side effects in like 10 years. Like, you wouldn't even like, as long as you don't do anything stupid, you should be fine. But regardless, let's just go back to this. So that was the score, which is pretty decent. Not amazing, but decent enough to get me top 1. This I will never get better than 6 then, for the simple reason that this card does not have enough cuticle or enough like work cores, and my CPU gets ass pounded by this Ryzen 16 core. However, he did this with the 1200K, so that's pretty impressive. That's pretty cool. Okay, anyway, so let's move on. Port Royal, no, never mind. I didn't have a 3090 with a 450 watt BIOS, so that was never gonna get better than like mediocre. So Firestrike is the one that I'm really like pulling ahead in. I have no idea how I pulled off the score. I managed to run the chip at 5.2 gigahertz with this run, and yeah, that chip was like on its edge, but it did it, and my clock speed was atrocious, but that's fine because it doesn't matter. We got top 40 in the world, and Extreme, we're losing to Vimpy, who's got a very impressive top score. He's top 40 in the world for Extreme, and then we're going to Ultra, and I am top 1 and 2 with 2 different systems. Somehow this one lost, I don't know. I think it's because the clock speed on my old AMD 69 was a bit better. Like, I think this old card I used to have back in September was just a better bin than the one I have now. But yeah, regardless, I don't care. I'm still up there, so it's all good. Okay, now what did I want to show you? Okay, so after the testing was done and all my shit destabilized, I was like, oh fuck, like, can't be serious, like, this is bullshit. It's like, is my stuff degraded? Like, what is that? Like, why am I crashing? Why am I seeing ring crashes again? And why does it keep happening? Like, it seems like the ring crashes happen like all the time. What do I do? So now today I have very good news. First off, for me, the chip definitely didn't degrade. And how do I know this? Because I tested it with no RAM settings and stock JDEC and stock VCSA at 0.9, stock VDD2, and it passes burn test with less voltage than what it passed burn test at on the week that I got the chip overclocked the first time. So it means the core the P-core E-core degradation did not, like, there was no degradation to the P-cores or the E-cores in terms of like what they can do at like a voltage. There was like, it was, if anything, they got better, but obviously that's impossible. They can't. I couldn't have, like, you know, the chip has been used, so it can't like get better. It's not possible. Like, the chip is the most complete once you've opened it. But anyway, basically the chip didn't degrade at all, but I found out what the problem was. Now, I also made a post on OCN about this, and on Bulldogs Discord, to help anyone else that maybe wanted some like Hail Mary solutions. Not that this is a Hail Mary, I think this is pretty logical, and I'll explain it to you guys. But first, to put some pictures. So let's just how do I organize this? I think I can just go like this, content, and then we're gonna go by date. Can I go by date? Hold on. So I want to go details, and there we go. Date, there we go. So this was weeks ago of my first attempt at so these were all outdated. So again, like the one, this one, and this one were old BIOSes. This one over here was in the new BIOS, right? But this one was destabilized, kinda, like technically. And if you can see, the VCCSA is 1.175 and VDD2 is at 1.1. And it seemingly passed HCI. It did pass burn test too. This one destabilized and all these. So what is stable now? Well, first off, I got this one stable. So what did I do? Very simple. I left VDD2 on auto, and I noticed something. All of a sudden, it was trying to do 1.3 volts. It's like, why? That's pretty interesting. Before, on the older BIOS revisions, it locked at 1.25. Then I thought to myself, oh, that's right. Shimino added this thing called IMC voltage calculation base or whatever. And I checked OCN, and apparently, like, yes, that is something you can use to increase VDD2 yourself, like, further. Like, having the board accurately, like calculate it, like, from a certain voltage base. And that should help, like, get it higher without actually causing the errors that you see. But funny enough, if you just leave it auto in general, so if you leave this on auto and if you leave this on auto, they match your RAM. If your RAM is 1.3 volts, like mine was here at this particular like configuration, but this does increase, but not linearly. So if you increase your RAM speed and your voltage, it doesn't actually like match it. It actually kind of calculates where it thinks it needs it, and that's in line with what this rail actually does. Now, what this rail actually does is it's a side rail. If I can pull up, there's a picture on Scatterbencher. I want to go Scatterbencher Alder Lake explained. Alder Lake explained, because here we go. So there's a brilliant picture. I'm not gonna quote his article and like that, but I'm gonna find the picture. This is not mine, obviously. I just want to show you guys what the picture is, because it's important. It's not this. It's not that. Here we go. I think this is it. No. I want this one. So Alder Lake. So as you can see, VCC GT and VCC IA power like these two rails, and I think, if I'm not mistaken, GT is the iGPU. If I'm not mistaken, I think it's the iGPU. You check. Yeah, I'm right. Yeah, that's the iGPU. So GT's iGPU. We never touch that. We never touch this voltage or the PLL or anything. There's no reason to. Okay. VCCIA stands for inter-architecture, and that powers the P-cores equals ring, obviously, because the ring feeds off the core cache rail, and then it powers the oh no, then I'm wrong. So that's all it powers, and this is important because sometimes you find that adding a bit of volts to the core cache rail actually helps ring stability when you're adding higher speed memory. And then we have the fiber from the VCC and AUX, which is the 1.8 volt rail, and that powers the equal L2, which you should probably not touch this either, because I found it actually destabilizes when you add too much for whatever frequency you're running on the equals. And then we have this is TX UDTQ. This is the TX one you see in the. This is not the RAMs one. The RAMs one is on the PMIC. Obviously, that's from the PMIC. But this is this would be this voltage here is this one from the fiber, right? And then obviously SA would come from the fiber, and then you get all these other ones that I have no idea what they do. Okay, this one powers the PCIe and DMI. Okay, that's cool. And this also powers VD2, which is this one, obviously. And so now, what? Oh, am I wrong? Actually, I might be wrong. VDD2. Where would it come from? No, I think it comes from Fiverr. I'm pretty sure it comes from Fiverr. I don't think it's. I don't think it comes from the board or the. No, I'm pretty sure it comes from Fiverr, or the CPU has like a separate rail or something. Yeah, more than likely it's like the situation where it's a separate rail then. But regardless, this voltage is a like supplementary voltage that like adds signal like it adds to the stability of the memory system by like helping with like signal integrity. And I read somewhere, I think you read it here. Here we go. Here it is. So it's this, and now why this is important is because if people have watched a few of my videos, you'd know that I said I've tried the washer mod and I've checked on OCN and on YouTube comments, and a few people now that I've come across have had issues like I have, where when you do the washer mod, you actually decrease the ILM mounting pressure, and that decreased pressure on the CPU actually like impacts the DDR pins, and you actually end up losing your training. Like you actually end up training like you can't train higher speed bins anymore. Like you get stuck at JDEC. So that was a bit like what some people have issues with certain RAM kits, is there simply isn't enough like the signal integrity isn't there for the training of like, I don't know, whatever, like 5600 C36 or whatever, 6000 6400. Like the training breaks because there just isn't enough like signal integrity. Like there's just not enough I would guess you could say pressure on the CPU, or maybe like the ICs themselves, if they had like, maybe they were better quality or whatever, it would help the signal and you would end up training them, which is why when I RMA'd my kit, I got a kit that worked after I thought my IMC was fucked or something, but it wasn't. I'm just being stupid. And funny enough, RMA'd the kit and it was fine. So this rail helps with signal integrity, and it's important because when this rail is not high enough, it kind of puts more stress on this rail. And what I noticed was when this, so if you notice on my hardware info, no, I'm wrong. If you notice the screenshot, when this is 1.3, I couldn't run this as high before. Even if I tried setting this high, even with the new BIOS, it wouldn't work because SA was adapted lower. So let's say I was in like 1.15 SA, 1.175 SA, thinking that was what I needed, which was what I needed before with 1.25 VD2. Now it works fine, kinda, right? It destabilizes, like I said, after a few days, which is something that we couldn't understand, and to a degree we still don't understand. We don't know why it happens, but I found that this rail increasing and then subsequently adapting this rail after this one has been set to its correct value by the board, lo and behold, now daily stable, rock solid, reboot stable. This should still work fine, I would assume. This did pass burn test, and I think this should work fine because the profile I'm on right now has adhered to this rule now, which is cool. Which is progress. It's fucking progress. So leaving your board to calculate what it needs as a supplementary VDD2 like supply voltage to help the subsystem, that seems to be the go-to. But then again, there's a lot of very good overclockers that set this manually and they find the correct value. Now you can do it, obviously you can fine-tune it. So let's say you fine-tune TX and VDD2 to be a certain number with your DRAM voltages, and then thereafter decide, okay, now just hold on, just give me a second. So thereafter, you end up having like, how do I put it? Almost like you can fix the, I don't even know what to call it, to be honest. Like, I genuinely don't have a technical understanding of why the subsystem is so like convoluted, but it is. And once you found the ideal values for this value and your DRAM, you can achieve like really insane like profiles daily stable. I've seen some insane stuff. Like if you look at OCN, you'll find guys like let me just go to the forum. So I'm just typing something. And who do I want to find now? I don't actually know everyone off by heart. What's his name? Damn, it's a lot of posts. Oh, that's awkward. Here we go. I think this is it. No, yes, it is. Wait, yes, closer. This one, is it? Yes, it is. Okay, so, this guy is super good at this, and I think if you find his actual, he has a screenshot later on where he shows the voltages, but basically he sets like them individually, and then you can actually find a way to stabilize like crazy speeds. Now that's kind of hard and generally not something I would like advise, because not everyone has the time to test that extensively. But if you can find a way, from what I've seen, you can actually get this rail up all the way to 1.6, get this up all the way to 1.6, and then you can actually start like finding an SA that works, and then you can get your DRAM in at like 7,000. So that's difficult to do. It needs a very good motherboard, not the one I have. Not that I could do regardless. I might not be able to get it, but you would need something like an Apex, a really good Apex, because some Apexes have variation. Some Apexes are pretty bad, some are pretty good, and you'd need like a Unify or like a Tachyon, and you could feasibly get some really insane configurations if you manipulate these two rails properly. But now there seems to be hope that you can actually achieve daily stability. And I'll keep going with that. I'll elaborate further from my screenshots. So this is fun. This is not like stable, but I managed to boot with this on auto. Now that it's applying enough voltage, I can actually train this, which is like something I've never touched before. So with this on auto, it can now train. Like I've tried to set this voltage before with all the BIOSes. It just never worked. But now it trains 66, and it trains 6 to 800. This even validated via CPU-Z, and obviously you can ask me, oh, Effect, where's the validation file? Problem was, I tried to get the account going. They emailed the verification email, and I never got it. I don't know why. I tried getting the email multiple times. I couldn't get it, so it's whatever. But this actually validated. It wasn't that unstable. It was quite unstable, but it wasn't like it wasn't like can't use Windows unstable. But yeah, so 60, 800, and these timings. And also, by the way, so one thing to note, this is not correct, and I'm going to go into that later on, because and I'll kind of break it down a bit later on. But yeah, so 6800 booted on my crappy board. Like, dude, like this BIOS is sick. Like, some people are saying this BIOS is bad. Nah, dude, no. This BIOS is sick. This BIOS is elite. This man Shimino, I don't know what the fuck he did, but good lord, like, damn, like, he literally made a good BIOS in December that fixed like all the baseline problems with like stability on Samsung sticks. This new BIOS is like, it's like, damn, dude, mic drop. Good job, dude. Like, fucking great job. That was cool. And I booted this too. So I even booted this. This is like, bro, I booted 6600 C34 on a fucking daisy chain 6-layer. Like, what, dude? A 4-DIMM 6-layer daisy chain, like at 1.45 volts as well, dude. Like, come on, this is mad. Now, obviously, this couldn't be like, I couldn't get this daily stable, but like, damn, this is mad. It actually booted this voltage, and yeah, it's impressive. It's cool. So what did I get working? This passed, and that's 20 runs in burn test, 400% HCI. This is stable. I just don't use it because there's no point. And I'll show you why as well just now. This is the one I'm on right now of dailying, and why I'm telling you it's stable is if you look at the date, 10 February, right? 10 February. Burn test passed, HCI passed. Today, early today. That's so wait, hold on. No, this is wrong. It's not that one, it's this one. There we go. So check the date. 13 Feb. It's this afternoon, early on, and I had TM5 going, anti-extreme, and TM5 fast. That's fucking... I know it seems weird, but 3 days, that's impressive. Like 3 days, I pass burn test, pass HCI, make no adjustments, don't retrain, I just keep fast speed on. Anti-extreme TM5 fucking passes 90 minutes, not a single error. Fucking brilliant, dude. Literally, like, this made my fucking day. I was like, oh my gosh, I passed TM5 after 3 days. This is awesome. And the best part, this is 1.42 volts. Whereas my previous 6400 was at 1.45 volts, if you check here. Right. So I use less DRAM VDD, VDDQ, more IMC VDD now, which is VDD2, and daily stable, reboot stable, TM5 HCI burn test. Fuck it, dude. That's fucking great, dude. Like, awesome. Just awesome. And now I'll explain why it doesn't actually matter about the... So I want to go to IDA, Alder Lake. Okay, so... Yeah, well, I can show you this one as well. So, this was 6400 C34, 3737, 78, right? And check the reads, check the writes, check the copy, latency. Now look at 36, 36, 36. Now it's not huge, obviously. It's not huge. It's not like a big difference, right? But it's beating it, and it's slower in latency by 0.4 nanoseconds, which to me, and you can agree with me, is pretty much margin of error. It's like, you're not really... 0.4 nanoseconds is like nothing, right? So this is 0.4 ns slower. It's 50... I don't know what this is. I think it's gonna be 101,500 gigabytes per second. So that's like 50... Should it be 50? Am I stupid? It's a 500 megabytes per second. This is 500 megabytes per second. Higher read. It's not big, but why? Why is this profile with these timings better than this profile? Why? How does that make any conceivable sense? And if it's not better, like let's say retesting these 10 times would have yielded like similar results. It's still equal. Why is this not like beating it? Well, you could say, okay, well TRCD and TRP are higher. Okay, well that's fair enough. But TCL's 34, right? Like, I've noticed this trend like quite a few times. So if I go back again to, this is perfect. Is it not this one? This one. So if we do 32, 30, 35, 35, check the reads, check the latency. If I go to 36, here we go. Wait, no, this is still the same. No, it's the same thing. Is it? Yeah. Wait, what? Why do I have two? Am I stupid? What? Wait. Hold on. Why do I have two of them? It's pretty dumb. Dude. Am I an idiot? Why did I do two benchmarks for the same fucking thing? Makes no sense. Oh, I fucked up. Oh no, I did. I'm stupid. I'm literally blind. Like, what? Dude, look. It's a 34. Dude, what can I see? Hello? Anyway. Okay. But dude, check. 34. What? Bro, how is 34? Like, what is that? Like, dude, what is that? 32, what are you doing? Why are you getting wrecked by 34? Like, the same TRC, same TRP, same TRAS, same TRC, same command rate, same fucking CPU clock. What the hell's going on here? Why is this, like, significantly faster? So, I've come to the conclusion that I don't think we exactly know how DDR5 works. Well, fucking no shit, Sherlock. But, like, dude, why are these fat configs so goated? Like, they're so goated. They're so good. Like, these fat configs, like, it's almost like, don't even bother fucking dropping the cache latency. Like, I'm about to fucking say that this is a result of error correction. Like, I almost want to say this is ECC. Like, this might be ECC at work. Like, if you guys know DDR5 has on-die ECC, this literally might be it, dude. Like, why? Okay, this is even better, dude. Why is this better than this, dude? Like, 36, 36, 36, 32, 35, 35. why is this losing? Like, what? Like, okay, yeah, obviously latency is low because cache latency is low, but why is this losing in terms of reads and writes? Like, why has this got better bandwidth? Like, is this error correcting? And that's why it's got low latency, but it's making errors, and therefore it's kind of losing in its overall like throughput. I don't know. Insert like, you know, hands in the, like, throwing up your hands emoji. Like, I don't know. Like, I'm shrugging. I have no idea. Now, on to the last bit. We have, if you go to OCN, if I go to OCN, I'll show you guys that I have a post here. I can go to the Discord, but I'm not going to go to Discord because I don't know that I'm supposed to, like, share Discord chats on YouTube. I don't know, that's completely fair. But, okay, so where was my post now? Was somewhere... Let me see. Cooling is right. I need 1.35. First. Damn. Oh, there we go. So, if you can look at this, this is quite important. So if you flash back to what I said a few weeks ago on my one video, where I spoke about this this video I linked. Okay, I'm not gonna go YouTube right now. About TRAS and the timing and how it works. So if you notice, this was not that unstable, right? This seemed to decrease stability. This even did so further. This one was stable. So what happened here? Let's talk about this. So you can see if you want to pause the video, you can read it yourself. Obviously, you have eyes, and I respect your ability to read. But basically what's happening here is TRAS with Samsung ICs cannot be flawed because Samsung ICs do not process data the same way Hynix do. As has been said by a lot of guys in the scene, the Hynix ICs seem to ignore the TRAS timing entirely. It's why you can flaw it. So TRAS on Hynix basically goes as low as the motherboard allows, and your TRC is irrelevant because TRAS doesn't exist. So your TRS and TRC just fall away, and you floor a lot of timings. Like a lot of timings on Hynix, you can like zero them because they just don't exist, and they don't affect anything. So I've seen like zero TRTP and shit, which is like fucking weird, right? Okay, but anyway, and that makes sense because TRTP again modulates TRAS. Like I said here, why I mentioned TRTP was 14 and the commander was 2. I don't know if the commander affects data burst, but I think it does. I think data burst should be... Probably not. I don't know. Whatever. As far as I know, data burst is 2. But yeah. So this doesn't work because 34 plus 14... Oh, sorry. 37 plus 14 plus 2 is not 38, quite obviously. It doesn't take a genius to find that out because 1 difference between 2. So this autocorrects to something. I don't know. There's no way of knowing because you'd never know. But whatever. This autocorrects to a value X, which is like kinda good but kinda too low. Probably the lowest the motherboard deems it can run at by itself, because the motherboard is smaller than I am. 53 is technically possible because if you use a calculator, 14 plus 37 plus 2 is 53. So that's the lowest possible value that I've worked out with my TRC-DRD plus TRT plus 2 calculation. And yeah, that is not stable. That is way too quick. That is like way too fast. That is like, it's not like that at all. It's like, no. IMC stress day, no. It's not doing that. It's not doing 90 TRC. It's not happening. So TRC is the more stressful timing, I think. TRAS isn't like the stressful timing, but TRC seems to be the one that kind of upsets the IMC, and that's why you would use TRAS to modulate TRC, because you can. That's why I noticed G.Skill did this thing with the TRAS, because in a world they wouldn't do this because there's no reason to. There's no reason to like if you wanted to set TRC higher, Like, even following the basic rules, there's no world where TRAS 96 is needed, right? This is not necessary. The reason why they made TRAS 96 is so TRC, which is this plus this, TRP plus TRAS, is much higher, and that decreases memory controller stress like significantly. It brings you to the place where you need to actually run most of these like retail CPUs daily, to help these unfortunate customers who are having some issues. Which I believe, yes, is a thing. I am firmly on the side of people are struggling with Alder Lake because I've seen it a lot, and yeah, I'm not gonna be swayed. So, anyway, this was not stable. I added 10, still not stable. I added 15 more, stable. Fucking miracle, dude. Well, yeah. So TRC, I'm not gonna try mental math that because it's embarrassing, and I don't want to make a mistake. So plus 78 is 115. So 115 TRC was happy with. And it passed burn test, and I went to stress test. It passed, as you can see, and I'm assuming it's still stable because I used the same logic to do my 6400 again, like I said. So what happened with 6400? If I show you this profile and this one. So what happened that night? Sitting down, trying to figure it out. I tried 1.45, and I was like, you know what, fuck it, let me try 1.4. 1.4 posted and trained fine. Seemed like it was possibly stable, but it kept on erroring at like run number 3 or something. I was like, oh, fuck it, I'll try 1.42. Try 1.42 volts at 64 TRAS or maybe 74 TRAS. Didn't work. Got to 84 TRAS. These settings, 84 TRAS, and fucking, there you go. 20 runs of burn test, and I was too scared to run more than 20 because I was like, I want it to be stable and I want to go to bed, so 20 runs of burn test has to do. 400% HCI, I pissed off to sleep and came back today to this depressing test that I thought I was going to fail, but somehow I come back and it's done, and I'm like, wow, it actually passed. So, problem solved, I guess, eh? Maybe. Again, like, this is all IMC dependent. Like, you literally have to find the ideal DRAM, VDD, and VDDQ settings, then find the ideal VDD2 and TX settings, then find the ideal VCSA setting that doesn't only work with these voltage rails, but also is now higher, so that now you can actually pass these tests days later because the ring is not stable anymore. So now you retest something and the ring is no longer crashing. The ring is no longer causing cache crashes. You're no longer seeing math errors that you would have seen previously because now you've got more SA to work with, enabled by seemingly the higher VD2. I don't know why, but that's what happened. I saw that adding. So for example, back to my tests, my screenshots to indicate why I'm not talking shit. If I go to the old one, this one, right now, notice I needed merely 1.2 SA, and obviously, like I said before, adding more increases instability, not decreases. It makes it more unstable. So with 1.25 VD2 and this voltage rail here, I needed these specific settings, and it would be fine with this on these two. Right now, come to today, it looks totally different. Now I need 1.42 volts on the RAM, and I need 1.25, so 50 whole millivolts higher. Now, like I said again, if this increased in the previous profile, it would have been unstable. Increasing it yielded stability this time, with this higher, much higher, and not just stability, but repeatable stability. TM5 and everything over here. Like, dude, this is all you need to see. Like, this is it. This is the Holy Grail. This is amazing. Like, this is it right here. Like, 3 days have passed, and it's still good. Usable. Still good. Fucking tremendous, dude. Tremendous. Like, if I shorten this a little bit, and yeah. So, I mean, can zoom in to you. And look at that. Amazing. Like, same voltages. So I used time configurator here, so same voltages. 1.25, 1.37. Well, it changes, so it fluctuates by itself, but I think if it sets 1.35 and it like LLCs up to 1.37, but yeah, you can see it does this on both. So it's like a range it kind of uses, but yeah, stable, repeatable, dailyable. Finally, fucking progress. And again, You're like, oh, effect, why don't you add more voltage, do 32? It doesn't help. It does nothing. Fucking amazing. It does nothing. It does nothing. It does literally nothing. There's no fucking point. Like, oh, dude, why don't you do 34, bro? Literally zero fucking point. It doesn't yield any performance difference. Like, look at this. Look at this. Look at this. Flats. Bandwidth. 34. Find it. Find it. Find it. Where's it now? 34. Is it here? This one. 34. Oh, no, no. This one. This one. This one. So, look at this. It doesn't win against... I'm so disorganized. It doesn't win. Like, why doesn't it win? It doesn't win, though. So why? Why bother running 34? It doesn't win. And if you compare, like, Geekbench numbers, it's like, again, it's like 100 points. And you're adding, like, 50 millivolts to get the capacities down. So what's the point? There's no point. Literally no point. So, yeah, at this point, I'm thinking, like... And I've noticed someone said that apparently Samsung IC seem to do better with the same settings as Hynix. Understandably so, because the entire way they access the memory is different because of the TRAS timing that doesn't exist and the TRTP doesn't exist. And yeah, so it's weird. But yeah, so basically adhere to the rule, the golden rule, which is TRTP plus TRCTRD plus 2 for Samsung ICs and Micron ICs. Hynix is weird. Hynix is just weird. And then if you want to be safe, play it like CAS latency plus TRC to RD plus 2. And that should be high enough to yield stability. But mainly you want to try and lower TRAS or higher TRAS, or you could sky it to try and increase TRC, thereby decreasing memory controller stress, thereby allowing for less errors, more stability, repeatability, and then you can daily it. Finally, you can daily DDR5 on Alder Lake. So, yeah, that's about it. That's everything, I believe. And I'm going to go correct my rail because apparently I can't read properly because clearly says it doesn't belong to the IVR rail. But okay. So, even still, Asus, it's not IMC VDD. This does not exist. This is not a thing. Not a thing, okay? It's that. Okay, cool. We're out. Peace. No, just kidding. It's cringy as fuck.